Hey, Algebra 1, today we talked about solving using square rooting. So just to kind of walk us through some of the stuff we've been doing here recently, we've talked about factoring, what multiplies and adds in a way that the binomials all multiply together to give you what you started with. Sorry. We talked about simplifying radicals, how to take a perfect square, a number that's not a perfect square and find factors that are a perfect square to simplify your radical down. For example, 24 is 4 times 6. Square root of 4 would change to 2. And we want to pick good numbers. Don't pick like 12 times 2 because that's not a perfect square. So really wanting to start utilizing that in this next chapter where we are solving using square rooting. So these first few were fairly straightforward, just square rooting both sides and just remembering that when you use square rooting, it's really a positive or a negative of that number. And so you want to watch out for square rooting negative values. So in number 10, we talked about how if you were to add the 5 over and divide the 6, you'd be trying to square root a negative number. And in Algebra 2, we call that two imaginary solutions. In Algebra 1, we just call it no real solution. Let's jump into a few that we didn't quite get to. Number 13, first step, let's subtract 3 to the other side to give you negative 800. Let's then take that negative 10 and divide that negative 10 over and getting 80. And then 80 is not a perfect square. You can put it in the calculator and it's roughly 9, not exactly 9. But really wanting to use perfect squares to basically rewrite 80 as two factors. For example, 16 times 5. Yes, 4 times 20, but 20 has a perfect square in it, 4 times 5. So we really want the largest perfect square possible. And so 16, the square root of 16 is 4. You still have the square root of 5. And again, it's the positive and the negative of this value. 14, another no real solution. Subtract 9, divide by 2, and you're trying to essentially square root a negative value, and you really can't do that. So there's no way up here at the very beginning. If you really think about it, when you square a number, it's always coming out to be positive. So whatever v squared is, that's a positive number. Then you're multiplying by 2, that's a positive number. Then you're adding 9 to it, that's a positive number. How in the world is that going to be negative 28? It's not. So that's why there's no solution. There's no value for v that you could plug in to make that work. Here's two more. Started by adding 6 over to b with 94. That makes 100. Divided by 196. These are two perfect squares. When you square root that, you get 10 over 14. And that simplifies to 5 over 7. I left number 16 for you. I did some of the initial steps, adding 13, dividing by 9. But this next step I did not do for you. So the next step is to square root both sides. And so I want you to basically tell me, how do you simplify the square root of 16? Like what perfect square goes into 16 and simplify that. But just remember that it is plus or minus whatever that value ends up being. I left 2 for you to try on your own. Tomorrow we're going to really talk more about factoring to solve. Today was more about simplifying or solving using square rooting. But tomorrow we'll talk a lot more about the zero product property when you factor something and basically set each factor equal to 0 to find those x-axis points or x-intercepts. So for example, b minus 2, b plus 7. Setting b minus 2 equal to 0 and then adding 2 over tells me that 2 would be a 0 on the graph. And if I do the same thing with b plus 7, subtract 7 to the other side, and negative 7 is also a 0. Now you want to be careful about just knowing this idea of flipping the sign, because as soon as you get something like number 21 where you have 3v, not like just x or just b, like you have 3v or 4v, when you have a coefficient, that means setting it equal to 0 becomes way more important. We're going to add 7 over, we're going to divide by 3, you end up getting a fraction there. So in class, we practiced this idea of factoring first, seeing what multiplies and adds, and then essentially what would make those factors come out to be 0 if you were plugging in different values. So let's do one that's a little harder, and the reason why it's harder is because it requires AC method factoring. What makes these a little faster, 22 and 23, they both have a coefficient of 1. They're both like 1 n squared. So those problems work out a lot easier than like number 24. So first of all, 9, 9, and 4 do not share a greatest common factor. They do not all have v in common. So the very first thing I did is I multiplied the a and the c value together. So 9 times negative 4 is negative 36. Now we're still trying to add to be this 9 in the middle. And so those numbers are 12 and negative 3. 12 times negative 3 is negative 36. If you add 12 and negative 3, you end up getting 9. So then we're going to bust the b, meaning we're replacing this middle value with the two numbers we just got from the puzzle. And if you were to put those together, you would get 9v. However, we do not want to put them right back together. We now want to do what's called group factoring. So this next part, 12 and 9 both have 3 in common. They also both have v on them. And so I end up getting 3v plus 4. These next terms both are negative, and so I just took out this negative 1. And then that gives me this repeating 3v plus 4. And now I have my factors, 3v plus 4, and then what I took out in black, 3v minus 1. So that is the factoring part. A week ago, that would have been the end of the problem. You would not have had any equals in the problem. You would have just factored, rewritten it, and that's it. But now you're doing that because your ultimate goal is to solve for what makes it 0. So now I have set both of these equal to 0 through v plus 4 equals 0, and we're going to subtract 4 to the other side. We're going to divide 3, and so one of your answers is negative 4/3. Alternatively, if you set the second one equal to 0, we're going to add 1, divide by 3, and you end up getting 1/3 as another answer. And so those are my two solutions to the problem, all done through factoring. So if you need to go back and look at that, please rewind the video and pause it in places. But I really want to see how many of us can do number 25 independently. So start by multiplying your a times c. Figure out your little puzzle, what's going to multiply to be negative 36, but add to be negative 9. That seems really close to the one we just did, by the way. And then go through your procedures of busting the b, group factoring it, so that once you have everything in factored form, you can begin to set everything equal to 0 to find these values. Good luck, and I will see you tomorrow.